Hello, we're on to the wrist and hand and the anatomy review for those. So when we talk about the wrist, we essentially talk about two different joints, which is technically more than that, but we're going to refer to the radiocarpal joint, which is the articulation between the radius and the proximal row of carpals, and the midcarpal joint, which is the articulation between the proximal row of carpals and the distal row of carpals. And these carpals that I'm sure you know, right, going from lateral to medial is your scaphoid, lunate, triquetrum, then pisiform, and then the distal row is trapezium, trapezoid, capitate, and hamate. The muscles of the wrist that are located on the forearm, there's an anterior compartment that consists of the flexor carpi ulnaris, which is right here, and your flexor carpi radialis, and then the palmaris longus that runs more midline, which is, you should know that some people do or do not have these, and some people may only have one. The posterior compartment consists of the extensor carpi radialis longus, right here on your thumb side, your extensor carpi radialis brevis, which is just inside the longus. And the nice thing about this picture, it also shows you the tendons, not just where all the muscles overlap. And then last is the extensor carpi ulnaris, again on the ulnar side. And the beauty of these muscles is they're named for where they are and what they do. So the flexor carpi ulnaris is a flexor of the wrist on the ulnar side, and because of it's on the ulnar side, it also performs ulnar deviation. Isn't that great? Okay, so just to kind of go through these individually, the flexor carpi ulnaris originates on the medial epicondyle of the humerus. It inserts on the pisiform and the base of the fifth metacarpal. It performs wrist flexion, ulnar deviation, and is innervated by the ulnar nerve. The flexor carpi radialis on the other side of the wrist, but also originates on the medial epicondyle of the humerus and then inserts on the base of the second and third metacarpals. It does wrist flexion and radial deviation and is innervated by the median nerve. The palmaris longus also originates on that medial epicondyle, inserts into the palmar aponeurosis. It assists wrist flexion and is innervated by the median nerve. Okay, now moving to the posterior side, we have our extensors. The extensor carpi radialis longus originates on the supracondylar ridge of the humerus, inserts on the base of the second metacarpal. It performs wrist extension and radial deviation. It's innervated by the radial nerve. The extensor carpi radialis brevis originates, the lateral epicondyle of the humerus and inserts on the base of the third metacarpal. Performs wrist extension, also innervated by the radial nerve. The extensor carpi ulnaris, again, originates at the lateral epicondyle of the humerus, but this time goes to the opposite side of the wrist, to the base of the fifth metacarpal. It performs wrist extension and, ulnar deviation. It's innervated by the radial nerve. So, when I said that these muscles are named for where they are and what they do, there's a bit of a dual role for these muscles. So, just to kind of show you in this little graphic organizer, if we're looking at the wrist motions, here's flexion, extension, radial deviation, and ulnar deviation. So that muscle which does flexion and ulnar deviation is the flexor carpi ulnaris. Like I said, it's named for where it is and what it does. That muscle that does extension and ulnar deviation is going to be the extensor carpi ulnaris, and so forth, to between radial deviation and flexion and extension. Excuse me. Joints and bones of the fingers and thumb. So we talked about the articulation at the wrist. Now we're looking at the joints and bones. Here are your carpals. Here are your metacarpals, your proximal phalangeals, your middle phalanges, middle phalanges, and then your distal phalanges. Now, of the thumb, it only has 2 phalanges, so it has one PIP or one IP joint. It doesn't have the DIP or the PIP, which is distal interphalangeal and proximal interphalangeal. Okay, and MCP is metacarpal phalangeal. Okay, so joints of the thumb, you have the carpometacarpal or your CMC joint, which is a saddle joint. That's where your trapezium articulates with the base of your first metacarpal. This does allow both mobility and stability. It's a very congruent joint, but because it moves in different directions, it does allow that mobility. So this is your, Pringles potato chip. It's concave this direction, but convex this direction. So at that first CMC, you have flexion, extension, ab and adduction, and opposition and reposition. We'll go through those thumb motions a little bit more when we're in class. Your MCP joint is a uniaxial hinge joint that does flexion and extension. I'm going to go back to here. So here's your MCP joint that does flexion and extension, and then also your IP joint that does flexion and extension. Right there. Okay, so flexors of the thumb. You have your flexor pollicis longus, which originates on the anterior surface of this radius, goes into the distal phalanx of the thumb, so it flexes all the joints, the CMC, the MCP, and the IP joint. That is innervated by the median nerve. The flexor pollicis brevis, and if you haven't figured this out, longus means long, and brevis is going to be the shorter muscle. It originates on the trapezium and the flexor retinaculum, which we will also discuss more in class, and inserts on the proximal phalanx of the thumb. Okay, so this is the proximal phalanx and the distal phalanx. It inserts on the proximal one. So this muscle, the flexor pollicis brevis, is going to flex the MCP and the CMC of the thumb. Sorry, I keep losing my mouse. Okay, it is also innervated by the median nerve. The extensors of the thumb, there's going to be extensor pollicis longus and extensor pollicis brevis. The longus originates on the middle posterior ulna and the interosseous membrane between the ulna and the radius. It inserts on the base of the distal phalanx of the thumb. So it all is going to extend all 3 joints, the IP, the MCP, and the CMC. This is innervated by the radial nerve. Extensor pollicis brevis, it's a little bit shorter, obviously, and it is originates on the posterior distal radius, inserts on the base of the proximal phalanx of the thumb, as opposed to the distal phalanx, and it does extension of the MCP and CMC. MCP and CMC, and is innervated by the radial nerve. The abductor pollicis longus, okay, that originates on that posterior radius, interosseous membrane, and middle ulna. It inserts on the base of the first metacarpal, so you're going to get abduction of the thumb just at the CMC joint. The abductor pollicis brevis, this little guy in here, this makes it part of your thenar eminence as well. It originates on the scaphoid trapezium and flexor retinaculum, then inserts on the proximal phalanx of the thumb. It's abduction of the thumb at the CMC joint and is innervated by the median nerve. The anatomical snuff box, it's created by 3 of the tendons that we just talked about. The lateral border is created by the abductor pollicis longus and the extensor pollicis brevis. And then the medial border is created by the extensor pollicis longus. Okay, muscles of opposition and adduction. and these are at the thumb. So your opponent's pollicis, and by the way, pollicis, if you haven't figured that out, means thumb. So the opponent's, it originates on the trapezium and the flexor retinaculum. Here's your opponent's right here. And inserts on the first metacarpal. It does opposition of the thumb at the CMC joint. It's innervated by the median nerve. The adductor pollicis brevis is right here. It originates on the capitate and the bases of the second and third metacarpals and the distal 2/3 of the palmar third metacarpal. Okay, so it's the bases of the second and third, and then the palmar third of the third metacarpal. Yikes. Okay, and inserts the proximal phalanx of the thumb. It does adduction of the thumb and is innervated by the ulnar nerve. Joints of the fingers. Okay, when we're looking at the carpometacarpal joints, I think I have a picture on the next slide. Yes. The trapezoid articulates with the second metacarpal. The capitate articulates with the third and fourth metacarpal. Hamate articulates with the fourth and fifth metacarpal. And I'm going to say this is a pretty important thing to remember, especially as we go through and palpate some of these joints. Your MCPs, or your metacarpal phalangeal joints, those kind of form your knuckles. Okay, those are considered a condyloid biaxial. They have 2 degrees of freedom. They flex and extend at that MCP joint, and they also ab and adduct. Okay, and we'll go through these shapes in class. Interphalangeal joints, both PIP and DIPs, they are uniaxial hinge joints, 1 degree of freedom of flexion and extension. And that you'll see here. I just put this slide in again just so that you remember where everything is. But here you'll see that the first metacarpal articulates with the trapezium, the second metacarpal with the trapezoid, the third metacarpal with the capitate, and the hamate articulates with the bases of both the fourth and fifth metacarpals. Okay, motions of the fingers. You have flexion and extension and ab and adduction, and again we'll go through this more in class because these all the fingers can abduct, but the middle finger cannot adduct. It just abducts in both directions, if that makes sense on a slide. Finger flexion. Okay, so now we've done wrist, we've done thumb, now we're going to the fingers. The flexor digitorum superficialis. So superficialis is going to mean it's fairly superficial, especially compared to the other muscles. Digitorum means that it's going to multiple fingers or to multiple digits. And you'll see that here. Okay, the origin is the common flexor tendon. Oh, okay, there should be a comma there, sorry. The humeral medial epicondyle. Okay, the coronoid process, and the radius, and it inserts on the middle phalanx of all 4 fingers. Flexion of the PIP and MCP joints of the fingers are performed by the flexor digitorum superficialis, and they're innervated by the median nerve. Okay, I'm going to interject here on some of the terminology you may see. I refer to these as fingers, and this as a thumb, but all 5 of them as digits. So this is my thumb, first finger, second finger, third finger, fourth finger, or second digit, third digit, fourth digit, fifth digit. To me, that's more clear. You may see it written different ways in different things, but as far as I'm referring to it, that's how I will. So, we have a lot more to get through. I have a limit of 15 minutes on this, so I'm going to say goodbye, and we're going to take up again on a second part with the flexor digitorum profundus. Okay, stay tuned.